In the stillness of space, where stars are born and galaxies collide, there are forces at work that we can barely begin to comprehend. Hidden deep within the fabric of the universe is a force so extraordinary that it defies everything we thought we knew about matter, energy, and reality itself. This force is antimatter, the shadow of matter, the mirror image of the very substance that makes up everything we are. For centuries, antimatter has existed only in the realm of theoretical physics, a speculative idea that seemed more like a fantasy than a tangible reality. But it is no longer just a dream. We have discovered that antimatter is not a figment of our imagination. It exists right here in our universe, waiting for us to unlock its secrets. It was in the early 20th century, at the dawn of quantum mechanics, that scientists first began to understand that for every particle of matter, protons, neutrons, and electrons, there exists a corresponding antiparticle. For every proton, an antiproton; for every electron, a positron. The discovery was made by Paul Dirac, whose equations predicted the existence of antimatter long before it was observed in the laboratory. And yet, despite its theoretical roots, antimatter remained elusive, a shadow that could only be glimpsed through the lens of advanced mathematics. It was not until 1932, when Carl Anderson discovered the positron, that the first actual antimatter particle was observed. But even then, it was a fleeting, momentary presence, existing for the briefest of moments before it vanished into nothingness. Over the decades, antimatter has evolved from a theoretical curiosity to a proven reality. But the road has not been easy. Particle accelerators, those massive, high-tech machines capable of reaching near-light speeds, have become our primary tool for creating antimatter. In these accelerators, particles are smashed together with incredible force, briefly creating antimatter particles in the wake of these high-energy collisions. And yet, even with all the power of these machines, the amount of antimatter produced is infinitesimal, so small it can barely be measured. In fact, the amount of antimatter created in the most advanced particle accelerators, such as the Large Hadron Collider, could fit into the space of a single grain of sand. And producing it costs an astronomical amount of money, trillions of dollars to make even a tiny amount. But despite the cost, despite the rarity, we continue to pursue antimatter because its potential is far too great to ignore. But even if we could produce antimatter, there is yet another challenge. How do we store it? Antimatter, by its very nature, cannot be contained in any conventional vessel. The moment it comes into contact with normal matter, it annihilates, releasing an immense amount of energy in the form of high-energy radiation. To solve this problem, scientists have developed magnetic traps, powerful electromagnetic fields that can hold antimatter particles in place, isolating them from any matter. These traps, such as the pinning trap, use magnetic forces to create a vacuum where the antimatter can exist for a brief moment before it decays. But even these sophisticated magnetic fields have limitations. The amount of antimatter that can be stored is minuscule, and the energy required to maintain these fields is enormous. We're talking about technology that is still in its infancy, but with each breakthrough, we edge closer to the day when antimatter will no longer be a theoretical oddity, but a practical resource. Every step forward brings us closer to unlocking antimatter's vast potential. Yet, the technology required to scale up the production and storage of antimatter remains a daunting challenge. The current cost of producing antimatter is prohibitively high, and the energy needed to contain it far exceeds the energy we gain from its annihilation. So why pursue it? Why expend so much time, effort, and money on something so elusive? Because antimatter is the ultimate energy source. Consider this. The energy released in an antimatter reaction is 100% efficient. Unlike conventional fuel sources, which are riddled with inefficiencies, antimatter provides the maximum energy possible from the smallest amount of mass. A single gram of antimatter can release enough energy to power a city for a day. And as our energy needs continue to grow, the stakes could not be higher. What if antimatter could solve the world's energy crisis? Imagine a world where energy is clean, abundant, and sustainable. In a future powered by antimatter, we would no longer be dependent on fossil fuels. The devastating effects of climate change could be mitigated, pollution reduced to near zero, and the energy demands of billions of people would be met with ease. Antimatter would produce zero waste. No CO2 emissions, no radioactive waste, just pure, clean energy. It would revolutionize how we generate power for homes, factories, transportation, and space exploration. The possibilities are endless, but so too are the challenges. Antimatter's greatest promise lies in space exploration. Antimatter propulsion could be the key to interstellar travel. Space travel as we know it today is slow, inefficient, and reliant on conventional rocket fuel. But with antimatter, we could travel at a fraction of the speed of light. Imagine a mission to Alpha Centauri, the nearest star system to Earth. With antimatter as fuel, a spacecraft could reach it in just decades, not centuries. The dream of interstellar colonization could become a reality. We could explore distant stars, planets, and moons, perhaps even find life beyond our own world. But there is a deeper question. Are we ready for this kind of power? Are we ready to unleash the unimaginable energy of antimatter upon our world and beyond? With such power comes great responsibility. If we can create antimatter, how do we ensure it is used safely? Ethical questions arise. Will it be used for the betterment of humanity, or could it become a weapon of unimaginable destruction? The same power that could light the world could also end it. The knowledge that could propel humanity to new heights could also bring about our downfall. As we stand on the precipice of unlocking the secrets of antimatter, we must ask ourselves, what kind of future do we want to create? The story of antimatter is not just a scientific one. It is a story of humanity itself. Our relentless drive to understand the unknown, to push the boundaries of what is possible. It is a story of hope, ambition, and caution. For in the pursuit of antimatter, we may find not only the key to a sustainable future, but also the keys to the cosmos itself. The journey ahead is uncertain, fraught with challenges, but it is a journey worth taking. For in the heart of antimatter lies the potential to transform everything we know, to power the world in ways we've only dreamed of. And maybe, just maybe, it will illuminate a path for us to explore the stars, heal the planet, and secure a brighter future. The pursuit of antimatter is a quest not just for energy, but for a new chapter in the story of humanity. And we stand at the beginning of that journey, staring into the infinite, waiting to unlock its greatest secrets.